Vertical ground. A body weighing tens of kilograms commits its full mass to a surface that offers almost no horizontal forgiveness. Muscle fibers load, tendons tense, contact points shrink to edges measured in centimeters. The expected outcome is loss of grip, rotational slip, a fall dictated by gravity and torque. The fall never comes. The contradiction appears immediately, balance is maintained, traction holds, and the force that should pull the body down instead becomes something to lean against. Only after this failure of expectation does the subject enter the frame: goats. Not mountain myths or exaggerated cartoons, but real ungulates whose anatomy has quietly rewritten what climbable means. Their hooves are not flat tools, but split structures with compliant outer rims and a hard inner core, a design that converts vertical pressure into lateral grip, increasing friction exactly where it should collapse. The paradox deepens because this system operates without redundancy. Each step commits weight before certainty. Each placement tests a surface that offers no margin for correction. From a physics standpoint, this is a gamble repeated hundreds of times a day, and yet the loss rate remains low enough for the species to persist. Ligaments store and release energy with brutal efficiency, minimizing muscular cost, but also operating near material fatigue limits. A misstep is not buffered by soft tissue or excess clearance. It is corrected in milliseconds by reflex arcs tuned to edges and voids. This is not agility in the playful sense. It is a constant negotiation with gravity under conditions that would rapidly exhaust or injure most mammals of similar size. What makes it unsettling is not that the system works, but how little safety it contains. There is no evolutionary padding here, no comfort margin, just enough structural tolerance to survive repeated exposure to near-failure states. When these animals are moved into environments without predators but with vertical escape routes, cliffs become territory rather than barriers. The landscape stops limiting movement and starts channeling it, allowing access to mineral deposits, sparse vegetation, and refuges unavailable to competitors. The result is ecological asymmetry created not by speed or strength, but by the ability to treat verticality as usable ground. Over time, this behavior scales, populations expand, and surfaces once irrelevant to herbivory enter the energy economy of an ecosystem. Plants adapted to inaccessibility are suddenly consumed. Erosion accelerates where hooves concentrate force, and rock faces begin to participate in biological exchange. None of this requires aggression or intelligence in the human sense. It emerges from a mechanical solution pushed just far enough past what intuition allows. The unease comes from recognizing that gravity never relaxed its rules. The body did not break them either. It simply learned to live so close to the edge that the edge stopped meaning safety at all. The stomach that should collapse. A ruminant of this size should not survive on what is effectively structural debris. Cellulose locked behind chemical bonds most mammals cannot touch, laced with secondary compounds meant to discourage consumption. The energy return should fall below metabolic cost. Fermentation should destabilize. Gas should accumulate faster than it can be released. The system predicts bloat, acidosis, failure. Instead, the process stabilizes and repeats. Goats carry a four-chambered stomach, but that description hides the real disturbance. A living bioreactor whose primary workforce is microbial, not animal. Billions of bacteria and protozoa break plant fiber into volatile fatty acids, and the host absorbs them as fuel, but the margin is razor thin. Shift the balance slightly, and the chemistry turns hostile. Too much easily fermentable material and acid production spikes, pH drops, microbes die, digestion halts. Too little, and energy intake collapses. There is no passive safety valve. Regulation depends on constant intake modulation and selective feeding that looks casual but is computationally dense. Goats sample, reject, return, and mix plant species, not for flavor but for biochemical compatibility, diluting toxins and pacing fermentation rates. This behavior is not learned once and stored. It is adjusted daily as plant chemistry shifts with season, stress, and soil. The unsettling part is how much of the animal's survival occurs outside its own cells. The goat does not digest food so much as maintain an ecosystem whose collapse would be fatal within hours. Gas must be expelled continuously, not in bursts, because pressure buildup is a mechanical threat. Eructation failures are not dramatic. They are quiet, progressive, and lethal. Yet the anatomy allows the animal to function while carrying this internal instability through cliffs, heat, and scarcity. When goats enter novel environments, this digestive flexibility becomes a weapon without intent. They can process browse that native herbivores cannot, including plants defended by alkaloids or tannins. Detoxification enzymes in the liver and adaptive shifts in rumen microbes extend the edible list faster than plants can respond. Energy that should remain locked in biomass is liberated and converted into movement, reproduction, and further consumption. The horror here is not excess appetite but efficiency under constraint. A system designed to barely hold together is suddenly given abundance, and instead of failing from overload, it scales. Vegetation disappears not in explosive waves, but through steady biochemical attrition. There is no moment of obvious imbalance, just a gradual draining of plant matter into bodies that should not be able to run this hot for this long. The stomach does not collapse because it never relaxes. It operates in a permanent state of controlled instability, and that is precisely what makes it so difficult to stop. Intelligence without mercy, a grazing animal is expected to trade cognition for efficiency, to follow gradients of food and safety with limited memory and minimal planning. Anything more would cost energy without clear return. Yet here, problem-solving appears where it should be metabolically wasteful. Gates are tested, not once, but in sequence. Fences are mapped as systems with weak points. Routes are remembered across seasons, even after long absences. Goats do not display intelligence as spectacle. They express it as compression, reducing complex environments into reusable shortcuts. The contradiction is that this level of behavioral flexibility emerges without a corresponding mechanism for restraint. Learning accelerates access, but nothing in the architecture signals when access should stop. This is cognition stripped of moral friction. Neurologically, the brain is not large by primate standards, but it is tuned for associative learning and spatial memory tightly linked to reward. Success reinforces exploration, and exploration expands the data set. In stable ecosystems, this simply makes an animal hard to exclude. In disturbed or artificial landscapes, it becomes a scaling problem. Once a goat solves a barrier, that solution propagates socially. Observation substitutes for trial and error, reducing risk and time cost. The population does not need to test every failure state. One individual pays the price, others inherit the result. This is not malice or intent, just information flow without damping. When relocated to islands or fenced reserves, goats treat containment as a temporary puzzle rather than a boundary. Their curiosity is not random. It is biased toward edges, seams, and transitions where systems tend to fail. From an ecological perspective, this shifts pressure points. Human infrastructure becomes permeable, and management strategies lag behind adaptation. The unsettling element is how quiet this intelligence is. There is no display, no signal of triumph, just a gradual expansion of reachable space. Vegetation loss follows routes rather than areas, corridors stripped first, refuges last. Native species adapted to static threats find themselves outpaced by a learner that does not need to outrun them, only outthink the barriers meant to protect them. Energy costs remain low because cognition replaces brute force. Instead of pushing harder, the system routes around resistance. This makes intervention feel strangely personal, as if the environment itself is being outmaneuvered. Yet nothing is happening beyond synapses strengthening in response to reward. The fear comes from recognizing that intelligence, when decoupled from ecological feedback, does not self-correct. It simply optimizes until something else breaks. In this case, what breaks is not the animal, but the assumptions built into the landscape it enters. Reproduction as a weapon. Population models predict that moderate reproductive rates should produce slow, manageable growth, especially in large herbivores constrained by gestation length, juvenile dependency, and resource availability. The math assumes feedback will arrive before damage accumulates. It does not. Goats reproduce at a pace that appears restrained on paper, typically 1 to 2 offspring per breeding cycle, seasonal rather than continuous, mortality that should thin expansion. The paradox is not speed, but timing. Sexual maturity arrives early enough that generations begin to overlap before ecological signals register as scarcity. Lactation draws heavily on stored energy, but the digestive system compensates, pulling calories from marginal forage that other species cannot use. Kids are mobile quickly, reducing parental cost and increasing survival odds in rugged terrain. Nothing about this is explosive, and that is precisely why it works. The system advances beneath detection thresholds, adding bodies just fast enough to avoid triggering immediate collapse. Each additional animal increases grazing pressure incrementally, but plants respond slowly. Root systems weaken before canopies vanish, soil structure erodes before slopes look bare. By the time visual cues suggest overpopulation, the reproductive engine has already banked momentum. Attempts at control run into another asymmetry. Removing adults does not reset the system, because juveniles already in the pipeline replace them with minimal delay. Sterilization, relocation, or culling must exceed birth rates consistently, not once, not briefly, but across multiple cycles. Any pause allows recovery that looks like resilience, but is actually stored potential, converting back into numbers. The unease comes from how indifferent this process is to intention. There is no swarm, no rush, no visible takeover, just bodies entering a landscape slightly faster than biomass can regenerate. In island ecosystems, where plant communities evolved without sustained grazing pressure, this imbalance is catastrophic. Endemic species lack defenses not because they are fragile, but because they never needed them. Leaves remain palatable, growth rates slow, recovery non-existent once browsed. Goats do not target rarity, they erase it by accident. The reproductive strategy does not adapt to feedback because there is none until the system tips. When it does, the signal is not hunger in goats, but silence in plants. What makes this feel wrong is that nothing violates biological rules. The numbers are reasonable, the physiology sound, the behavior ordinary. Yet placed in the wrong context, moderation becomes a weapon, and stability becomes the mechanism by which collapse is delivered slowly enough that intervention always arrives late. The island that loses. First, isolation is supposed to function as a filter, limiting invasion by distance, reducing competition, slowing change in theory. Separation buys time. In practice, it removes defenses. When goats arrive on islands, often by accident, sometimes by design, they encounter systems built on the assumption of absence. No large, persistent grazers shaped these plants. No hooves compacted this soil. Nutrient cycles evolved around slow input and slow loss. The biological limit here is recovery speed, and it is immediately exceeded. Browsing pressure begins at reachable heights, then climbs, literally, as goats access cliffs and slopes that once served as refuges. Plants respond by reallocating energy to survival, not growth, which reduces seed production. Fewer seeds mean fewer replacements. The math turns negative quietly. Soil follows. Without continuous vegetation cover, wind and rain remove thin layers that took centuries to form. This is not erosion as disaster, but erosion as accounting error. Grams lost faster than they can be replaced. The paradox is that goats do not need to dominate directly. They do not outcompete native herbivores through aggression or speed. They simply remain active where others pause, feeding longer, higher, broader. The island loses first because it has nowhere else to shift pressure. Continental systems can absorb displacement. Islands cannot. Every hectare matters, every niche already filled. As goats simplify plant structure, insects disappear, then birds, then the functions those species performed. Pollination declines, seed dispersal collapses. What remains is not a barren wasteland at first, but a quieter version of the same place, fewer interactions per unit time. This is ecological thinning rather than destruction. From a distance, the system still looks intact. Up close, it is hollowing out. The unsettling part is how reversible it appears until it is not. Remove goats too late, and plants fail to return because the soil profile that supported them no longer exists. The system crosses a threshold without spectacle. Conservation models often assume that removing the stressor restores the baseline. On islands affected by goats, that assumption breaks. The past state becomes unreachable, not because of continued damage, but because foundational layers are gone. Goats do not adapt to islands. Islands adapt to goats by losing complexity. This is not an invasion defined by violence, but by persistence, interacting with vulnerability. The horror emerges from scale mismatch. A body evolved to exploit marginal ground meets a system where all ground is marginal. Nothing intervenes automatically. There is no balancing predator, no seasonal reset. The island does not fight back. It simply yields, one process at a time, until what made it distinct is no longer present to recover. 9 years to silence, eradication. Timelines expose a final contradiction. Removing a common herbivore should be simple, predictable, finite. Instead, it stretches into a multi-year operation that behaves more like system shutdown than pest control. In documented island cases, complete goat removal has taken close to a decade, not because the animals are numerous beyond measure, but because the last survivors operate at the extreme edges of detectability. Population density drops, but efficiency rises. Individuals alter movement patterns, reduce social contact, exploit terrain that was always available but previously unnecessary. The biological limit here is not endurance but detectability. A mammal this size should not be able to disappear into open landscapes, yet it does. Surveillance technologies escalate. Ground teams, tracking dogs, aerial surveys, radio collars on sterilized Judas goats used to locate the final groups. Each step acknowledges the same uncomfortable fact. The system resists being turned off. Energy costs invert. Finding the last few animals consumes more resources than removing the first thousands. This is not because goats become smarter in a narrative sense, but because low-density living is already within their behavioral repertoire. They can subsist alone, browse broadly, and survive long periods without contact. The paradox sharpens when success arrives. Once the final animal is removed, the ecosystem does not rebound on the same timeline. Plants may take decades to recover, if they do at all. Some species are already gone. Soil may require artificial stabilization. The biological debt remains after the biological agent is erased. What feels wrong is that the goats were never malfunctioning. They were executing survival algorithms with high efficiency under constraint. The conflict arose because those algorithms encountered a context without buffers. The 9 years are not punishment or struggle. They are the time required to unwind an interaction that scaled quietly and lawfully. Silence arrives gradually. Hoofprints stop appearing. Browsed shoots persist. The absence itself becomes the signal. This ending lacks triumph because nothing was defeated in the conventional sense. A system was corrected by force because it would not self-correct. The lingering unease is recognizing that nature did not choose sides. The same rules that allowed goats to persist on cliffs, digest toxins, learn boundaries, reproduce steadily, and hollow out islands also ensured that removing them would be slow, expensive, and incomplete in its repair. The story closes not with resolution, but with a recalibrated baseline, a reminder that when a biological system works too well, the only way to stop it is to break the context that allows it to function.